everybody, Jeremy Blum here with my 6th episode of the Arduino tutorial series sponsored by Element 14. Congratulations on making it through the first 5 if you actually followed through all of them. If you haven't, go back and check them out now because these are going to start to get a little bit more difficult now. Not too bad, but I just want to give you a heads up. So for the next 4 episodes, I'm going to be talking about different types of serial communication methods that you can use with the Arduino. This week I'm going to be talking about specifically just serial communication between the Arduino and the computer, simple TX-RX serial communication. We're going to use it with a programming language called processing, which is the language that the Arduino programming environment is based off of. Processing is great for drawing graphics and doing things like that, so we'll experiment with that this week and next and have the information from the Arduino control processing and vice versa. And that should be pretty cool. After that, in the coming tutorials, we'll move on to I2C, SPI, and wireless communication techniques. So I hope you're looking forward to it. I certainly am. Let's get started with general serial communication. Before we actually start communicating with the computer, let's talk a little bit about how we do this with the Arduino. If you look at the Uno, you'll see that there's a TX and RX pin on digital pins 0 and 1. Now you can use digital pins 0 and 1 while you're running your program for input and output. But during programming, these pins are multiplexed to be used as the programming pins for the Arduino. The RX pin is the receive, the transmit pin is the transmit. When we call serial functions in the Arduino programming language, we're using these pins to talk back and forth between the computer and the Arduino. When you do this, you'll notice that the TX and RX LEDs will flash to indicate that you're sending or receiving data. The same story holds true for the Nano. Here you can see the TX and RX pins on the Nano. The Mega is a different story. You'll see that there's still TX and RX on pins 0 and 1, but there's also 3 more serial interfaces that you can use for communicating either with other Arduinos or just any other device that accepts serial communication. This comes in useful later on if you want to be able to simultaneously program the device and have it plugged into a separate serial interface. When you plug your Arduino into the computer via USB, you're actually making a serial connection to the Arduino. You might have noticed that the Universal Serial Bus, or USB, plug on your computer has 4 pins on it. Transmit, receive, power, and ground, just like on the Arduino. An important thing to note is that transmit always gets hooked up to receive, and receive always gets hooked up to transmit. That's because the receiving line for the computer is what's being transmitted from the Arduino. The same goes the other way. What's being transmitted from the computer is received by the Arduino. Now, serial interfaces operate at around plus or minus 15 volts. So in the case of RS-232, or the interface that serial uses, negative 15 volts actually represents a logic 1, and positive 15 volts actually represents a logic 0. This is obviously much different from the 0 and 5 volt TTL or transistor logic that the Arduino uses. To deal with this, a converter chip is used on the Arduino to translate between the 2 logic levels. You don't have to worry too much about this, the Arduino takes care of it for you. If in the future you're ever using an Atmega microcontroller directly, you'll have to put in a converter chip yourself. A common example is a Max 232 converter. To get us started, let's just make a very simple program that we can use to send one character to the Arduino and receive that character back, just to confirm that the Arduino got it, and then we can use it to do something more interesting like control an LED or a motor or something. So we'll start our serial session just like we always do using serial.begin, and this will allow us to communicate with the Arduino via serial. 9600 is the baud rate at which we're communicating. The baud rate is just an indication of the bits per second, basically the communication speed. 9600 is a pretty common value to use, but you can use other ones too. The first thing we're going to do is wait until we get something from the computer, and that's what this while loop is going to do. Serial.available equals 0. So what the available function of the serial class does is it checks to see if there's something waiting for the Arduino that we've sent from the computer. If we haven't sent something, it'll just keep looking. So it's just going to stay on this line and keep looping through this line until it gets something from the computer. Okay, once it does get something, we're going to read it into a variable. And we'll just for now assume that we're sending it an int, just to make things easy. So we'll do serial.read, which is going to read our input from that we send to it from the screen. And we will echo the output. So we'll do serial.println, and we'll echo that output back to the user. So we have our Arduino plugged in via USB on the other end. There's nothing connected to it, just the Arduino. We just want to test the serial functionality. So if we send it a 1, we should get a 1 back. What? A 49? Oh, that's weird. What happens if we 0? 48. Huh. That's peculiar. Okay, let's try to look into why we're not getting the same numbers back that we send it. Alright, the answer to our problem lies in data types. If you go to Google and just look up an ASCII table, ASCII,
you'll find something like this. And this breaks down to you the different types of data types and how they relate to each other. So we're sending a character or a char, and we're sending a character of 0 or 1. And you'll notice if you look over here, you can see that the decimal representation of 0 or 1 is 48 and 49, exactly the numbers that we were getting. Okay, so here's what our problem is. We're clearly sending this, but telling it it's an integer, when really it's not an integer that we're sending it a char, which is really a byte of data. It's different. So we need to handle the conversion on the Arduino end so that we print back out the right stuff. Let's go do that. There's actually a very simple way to fix this, assuming you're only going to be inputting integers from the computer. And this is it. Are you confused? Well, let me explain why this is happening. The reason why this fixes it is we're sending it a char 0, not just a 0. Note that the 0 is in single brackets. That indicates that it's of the character type to the Arduino programming environment. Remember, we looked at the ASCII table and saw that 0 as a character is represented as 48 in decimal. So if we know that we're sending it a 0 or a 1 or a 9 or whatever through the terminal, and we subtract the char value of 0 in decimal, it'll subtract the correct number and return what the actual integer value is. So, for example, if we send it a 1 on the terminal, which has a char value of 49 or a decimal value of 49, and then we subtract the decimal value of 0, which is 48, we'll get a 1 back. This should fix our problem. Let's upload it and see what happens. Perfect. That's more like it. Now we're getting the numbers in that we send to it. Okay, now let's do something more interesting. Let's have this control an LED and report back to us whether or not the LED is on. Alright, we're just going to use the onboard LED to make this nice and simple for us. We'll set it to LED pin 13, which is the one that's on the board already, remember. We have to set it as an output. Pin mode LED pin output. Okay, so we've got our weight. We've got it reading it in and making it an integer correctly now. So let's take a look at what we're doing here. We'll say if the value that we read in is equal to 1. Remember, you use a double equal sign when you're checking for equality. If the value is equal to 1, then we will serial.println a nice little message back to the user that says LED is on. Okay, and let's put this in brackets. And if that's the case, we also have to have it actually turn the LED on, of course. Otherwise, that wouldn't do us much good, would it? Digital write LED pin high. Okay. And now we need to check if the value that we get is a 0. So we'll send it a 1 to turn it on and a 0 to turn it off. If val equals 0, serial.println LED is off. And you can have this say whatever you want. Digital write LED pin, and now we'll turn it off. Okay, make sure we get our brackets in there. Okay, that looks good. But we need to check one more thing, right? We have to make sure that we check for what happens if it's neither of those. So let's actually make this an else if statement. An else if statement only bothers to look at this if this one didn't happen. It just makes the code execution a little bit more efficient. You could have it as an if also, but we'll use an else if. It makes it a little bit better. And then we'll add an else. So this is what happens if this doesn't happen and this doesn't happen. It'll execute the else statement. And we'll just have it say back to the user serial.println invalid, so that they know they did something wrong. Okay, and we don't need to have this echo back anymore. Let's see how that works out. Alright, let's see if this actually works now. Send it a 1, LED goes on. Send another 1, of course it should not do anything. Send it a 0, LED goes off. 1 on, 0 off. Okay, cool, that looks good. And you notice that the TX and RX LEDs also blink because we're sending and receiving data. But now what happens if I send something like a V? Invalid. Okay, good. That does what we want. Now what happens if I send a whole bunch of garbage? Whoa, it prints out an invalid for every character. Okay, it looks like we need to make one more simple change to our program to get this doing exactly what we want. The last thing we're going to add to make sure that we don't get a ton of invalid inputs when we put in more than one character is we're going to flush out the serial buffer. And to do that, you just do serial.flush. Similar to flushing a toilet, you're basically just removing all the garbage. Anything else that we don't want gets removed. So since we're only looking for one character here, once we run serial.flush at the end of this loop, it'll get rid of everything else and then start looking anew. So now we should only see that invalid problem happened just once. Let's upload this and see how it works. Okay, I'll send it a 0. LED's off. 1 LED is on. And a bunch of garbage. And just 1 invalid. Okay, perfect. This program's now doing what we want. We've got some simple, basic serial communication between the Arduino and the computer. And you can, of course, expand upon this and send it all kinds of different commands to do all kinds of interesting stuff. But for now, let's move on to do something a little bit different. We'll use the Arduino to control the computer. Here I have a simple 10K potentiometer hooked into the Arduino. Remember, we've used this one time before. You don't actually have to use a breadboard for this because we already have all the pins that we need. The red gets hooked into voltage, the black gets hooked into ground, and the green gets hooked into analog input 0. Now let's go to the computer and program it to read the input from the potentiometer and send it back to the computer so that we can use it in a program that can read inputs from a serial port. This program is going to be very simple. All it needs to do is get the data and send it over USB to the computer. So let's define our pot pin to start off. That's where the pot is connected to. Analog input 0. Do our setup function as we always do. Start our serial object because we need that to both send or receive. 9600. And now we're just going to loop through and keep checking the value of the potentiometer. The important key here is that you add a little bit of delay each time, because if you're sending data at 9600 baud, that's a lot and way more than you need, and it's not going to give time for the analog digital converter on the Arduino to update fast enough. So we'll start off by reading the value and mapping it. Now the reason I'm going to map this right away is because I'll give you a little giveaway here. We're going to use it to control the color of something on the screen, and colors are controlled from 0 to 255. They're 8 bits, unlike our analog input, which is 10 bits. So we'll read this in, and we'll convert it from a 10-bit number down to an 8-bit number. And we've done this before, remember. So we'll go from 0 to 1023 to 0 to 255. So what we'll be doing here is we're just sending the computer a value between 0 and 255 that we can use later on to do something cool. Serial.println. Remember, println isn't just for sending it to the terminal, it sends it to the computer. So we'll print that val. And I'm going to put a delay of 50 milliseconds in there. Should be sufficient. You could actually probably do less than that, like 10 milliseconds, but this is fast enough. Alright, let's get that on the Arduino. And now we're going to write our processing program to deal with grabbing that input and doing something cool. Okay, so we're going to be using a programming environment called processing to grab the input over serial and use it to change the color of something on the screen. Processing is perfect for working with the Arduino because the Arduino programming language is actually based off of it. So if we just search processing in Google, processing.org is the first thing that comes up, and that's where we want to go. Alright, so just click on download processing, and just like Arduino, you don't actually have to install it, you just download the folder and run it right from there. So pop it onto your desktop or wherever you want to put it, extract it, and then run processing. Now our processing programming environment is open. Does it look familiar? It should, because the Arduino programming environment is heavily based off of it. So it should be a familiar place for you to start working. Now I'm not going to go over all the details of how to use processing because I don't want to put you through the terrors of learning an entirely new programming language, but I'll just give you enough to get you started. You can use basically any programming language to get input from over a serial connection. Processing is just one example. So the first thing we'll do, very similar to Arduino, we're going to import a serial library. In Arduino, serial is imported by default. In processing, you have to import it. But we've imported libraries in Arduino before, so you should be familiar with that. The next thing we're going to do is create a serial object that we're going to call port. And I'm going to define an initial variable called brightness, because we're going to be controlling the brightness of the color on a screen. And I'm going to initialize that to 0. This is the value that we'll be changing using the potentiometer. Okay, now just like Arduino, we're going to have a setup portion of our program. And in processing, it's heavily graphics based. So one of the things you set up in the setup part of the function is the size of the graphical window that you want to open. So I'll make it 500 pixels by 500 pixels. And now I'm going to initialize our serial port. Similarly to how you do serial.begin in Arduino, it's a little bit different in processing, but a similar idea. We're going to do port equals new serial. This, because we're running it on this class. I happen to know that my COM port is COM3. Go check what your COM port is in your computer and make sure you set it to that. If you're on Mac, it's going to be a little bit different. It's not going to be represented like COM3. Same thing goes for Linux. It'll be like /dev or something like that. And we'll do port.buffer until \n. So let me explain what that's doing. Buffer until is essentially that same thing as that while loop that we were running earlier. It's just waiting until it gets something. \n is a special character that indicates a new line. So remember, we're doing print line, which prints a carriage return after it sends you each value. Every value you get from the terminal is on a different line, if you remember. The thing that tells us to go to the next line is \n, which you can't see, but the computer's terminal program can. So we're going to know when we're getting a new value by looking for that \n. And now we're going to have another thing called draw, and this is what updates the screen. This is going to update our little 500 by 500 window, and this keeps repeating. Draw automatically keeps repeating to update the screen. And all we're going to do is change the background color of it to get started. Background 0, 0, brightness. Now, the values for this are RGB values. So I'm just going to set the red value to 0, the green value to 0, and what we'll be changing with the potentiometer is the blue value. So by brightness, basically what we'll be doing is we'll be turning it from black up to bright blue, which is a value of 255. Okay, and now we're going to look for a serial event. This, when you have the serial class running, will automatically check for that serial event based on the buffer until that we have specified. Serial event, serial, and remember we named it uppercase serial. Remember we named our object port. And all we're going to do is we're going to look for that value, and we're going to say brightness is equal to that value that we get over the serial port. Brightness equals float port dot read string until, and we're going to look for that \n character again because we want to read up to that, and that should get us our value. And all this is doing is converting that value into a float so that we can use it in our background function. And that's it. Let's run this and see how it works. Always make sure you save first, and then you hit this little run button to run your processing program. I'll turn the potentiometer, and you can see the screen gets brighter. As I turn it all the way up to the top, the blue value goes 255, and I turn it back down, and we're back down to black. Alright, awesome. You just wrote your first program that sends data from the Arduino to processing. You can do a million things with this, and we'll do more with it next week. But for now, that should be enough to get you started. And remember, you can always go to the processing website and look up tons of examples on how to use it.
Okay, and that's our intro to serial communication with the Arduino. Next week, I'm going to be talking about I2C, and then the week after that, SPI, which are two other methods for communicating between the Arduino and integrated circuits. If you have any questions about anything I did this week, feel free to post a comment on YouTube or on Element 14 or on my blog, JeremyBlum.com. And as always, I'll be posting the source code, including the processing source code that I used this week, up on my website, and I'll have download links all over the place so you can find that. And that's it. I will see you guys next week. Thanks a lot for watching. Thanks to Element 14 for helping me to sponsor this video series. They were kind enough to provide a lot of the materials that I'll be using to create these tutorials. Feel free to go visit their website at element14.com. Check out their community, which is a great place to talk to people about electronics, the Arduino, and basically anything else engineering related. And they also have a store where you can buy a lot of the parts that we'll be using in these videos.